Hi everyone, we are going to do lesson 4.5 over video. So the idea is please copy these notes down and watch the video and copy these notes into your package and then do the homework. Okay, so in lessons leading up to 4.5, we have explored A, H, and K and how they manipulate our parent function, but we have only done these variables one at a time. In lesson 4.5, we're going to connect them all together and we're going to graph them all at the same time. We're also making a big connection between A, H, and K and the formula for a general parabola, which is this one. So this is the big guy here. This is the thing you have to know, this unit. So just as a reminder, we said that one form that we saw a parabola in is x squared plus k, and this was in charge of the vertical movement up and down. Okay, and the way we move our parent parabola is by adding or subtracting to our y values. Okay. Similarly, but different at the same time, we looked at y equals x minus h squared, and we said that the big difference here was that the power of 2, the h value is within the brackets and the power of 2 applies to the h, whereas in y equals x squared plus h, the power of 2 only applies to the x, and the k, sorry, I said h, I meant k, the k is on the outside, okay? So that indicates to us that this is a horizontal movement, and horizontal is left, right, in which case we would manipulate our x values. We also looked at let's write it like this, y equals x squared, a times x squared. And we said our a value actually has two different meanings. So we said that the sign of a tells us whether it's facing up, the parabola is facing up, or if the parabola is facing down. We also said the magnitude of a has an effect. And magnitude, remember, is size without sign. Okay, so -5 has a magnitude of 5. We just ignore the sign. So this tells us if it's compressed, okay, or stretched. Or stretched, okay. And we know it's compressed is if the magnitude is less than 1. So remember, the magnitude means the size, not the sign. So for example, y equals 2/3 x squared or y equals -1/4 x squared are both going to be squished. Okay, so they'll look a bit fatter, and one of them will be facing downwards, the -1. Stretched is when the magnitude of a is greater than 1. So for example, y equals 5x squared or y equals -2x squared. They're both skinny, and one of them is also facing downwards. Okay, so now we're going to wrap this all up into a bow, okay? And in this box, I just want to generalize this for you. So basically, the parent function is the parent parabola that we already know, the one that goes through 0, 0, okay, 0, 0, 1, 1, -1, -1, 1, etc. So we know what that looks like. And what we're learning how to do is apply transformations to make it look like y equals ax minus h squared plus k. And the way we do that is we manipulate or we transform the x and the y values. Okay, so what we have to do is we have to add h to the x values, and we have to multiply y by a and then add k. So I know that sounds like a lot, but we're going to do a bunch of examples now. And I want us to look specifically at what we call vertex form. So this is a parabola here in vertex form. And the reason it's called vertex form is it's because it's easy to see what the vertex is. The vertex is very simply HK. So I look at what my H value is, I look at what my K value is, and I automatically know what my vertex is. Okay, so let's look at each of these together. So just a reminder, if I look at A, the A value here, okay, A tells us two different things. A tells us whether or not our parabola is reflected. So if A is positive, it's facing up. If A is negative, it's facing downward. The second thing it tells us is if it's compressed or stretched, or neither. Okay, so we can do that by looking at the magnitude of A. The K value tells us about the vertical translation. And that's up or down. And then finally, and I'm going to switch to green because our H value is completely different. The stuff in orange, those are vertical changes. The stuff in green that I'm about to write are horizontal translation. Okay, that impacts our X values. It's our X-axis. So this is left or right. So in order to apply the transformations in orange, I have to manipulate our Y values. So for these, I would manipulate Y values for the transformations in orange. For the horizontal ones, I would manipulate my X values. So I do that by adding, subtracting, multiplying. Okay. So what we're about to do is get into basically the kind of question I would ask you on a quiz or a test, which is using the table below, map the points y equals x squared to the graph y equals -2 x plus 3 squared plus 7. So what I can see is that this graph is reflected in the x-axis because there's a negative here, so I know it's facing down. I also know that the magnitude is 2, so I can see that it's going to be skinnier, or let's say stretched, by a factor 2. And I can see that it's going up 7. And is that left or right? Well, I know that H is actually -3. It's going left 3 units. Okay, how do I put that in this table? How do I use this table? Okay, so here we go. The first thing we're going to do is fill in this gray portion of the table. The gray portion is reserved for the parent function. So the parent function is always the same: -3, -2, -1, 1, 2, 3. And then I'm putting my points in for, remember, the parent function. So even if I forget, I can just sub these points into y equals x squared, okay? Now, what I want to do is fill this table in by point mapping. So what I'm going to do, and probably the one thing that really takes a bit of remembering is that BEDMAS applies here. So what do I mean by that? Well, in BEDMAS, we know that we multiply before we add and subtract. Same with transformations. So I know that in order to apply my reflection and my stretch, I have to multiply by -2. So I always apply my A value before H and K values. So what does that mean? So my first step in this table is I'm going to take all of my y values, just the y values, right? Because I'm only multiplying by y. And I'm going to multiply these by -2 in order to apply my downward facing parabola, my reflection, and my stretch by 2. So this becomes -18, -8, -2, 0, -2, -8, -18. Okay, next, now the next two things can happen actually at the same time. What I'm going to do is I'm going to apply my shift down, upwards. So I need to add 7 to all my y values, but they're the red y values, not the blue ones, because I have to multiply by -2 first to apply the stretch and reflection first, and then I shift it up and down. All right, and then for my h value, I can see that my h value is actually -3. I have to move left 3 units. So what I'm going to do is shift my entire graph left 3 units. And then what I do is I plot the green points. So I plot the things that are on the outside. So what I've done here effectively is I've taken the point on my parent function 3, 9, and I have mapped it to -6, -11. I've taken my point -2, 4, and I have mapped it to -5, -1. So I'm looking on the outside of my chart to get these values. I've taken -1, 1 and mapped it to -4, 5. All right, so I'm not going to write them all in. I am, though, just going to plot them. So here we go. I've got -6, -11. It's a little bit off, but we can probably squeeze that in. -5, -1. -4, 5. -3, 7. -2, 5. -1, -1. And 0, -11. And I should be able to see that, yes, this is in fact facing down. It is stretched by a factor of 2 because it looks skinny. And I have moved it 3 units to the left and 7 units up. Okay, so there's a lot of writing on this page, and I don't expect all that, but I do want to see what's inside this chart. Okay, that to me is more important than the graph. When I go to graph, mark your tests, I'm more interested in what's in the chart than what's on the graph, okay? Because if one of them is incorrect, the other one's also going to be incorrect. So please make sure you're doing your chart properly. Okay, so now I'm getting into questions that are going to force you to get to know y equals ax squared plus, ax minus h squared plus k a little bit better, okay? So I've given you some features of a parabola, and I want you to put them together to tell me what the equation of that parabola is. So for example, if this is translated 7 units down, I know that k should be -7. If it's reflected about the x-axis, I know that a has to be a negative number. If it's compressed by a factor of 1/3, and I know a is negative, with both that information, both those pieces of info, I can conclude that a is -1/3. If it's translated 2 units to the right, well, I know my h value, because it's right, it's positive, h is going to be 2. So I get -7 x minus 2 squared. Remember, h is positive, but the sign between x and h is a subtraction. Sorry, this should be -1/3. Okay, -7. So if I were to graph this function, it would have these parameters. All right, opposite question. I'm listing all the transformations of this parabola. I know it's reflected in the x-axis because a is negative. I know that it's stretched by a factor of 5. I know it's translated. Which way is that, left or right? I think it's right, because h is positive 7. 7 units. And lastly, it's translated up 13 units. Okay, so when two items are congruent, they have exactly the same shape and size. So, for example, if I take a parent function, the y equals x squared, and I just shift it left and right and up and down, not actually changing the size. So two parabolas are congruent if they have the same vertical stretch or compression. So in other words, magnitude of A. So for example, if I have y equals 2x squared and y equals 2x minus 1 squared, these are the same shape. Just one is translated to the right by 1 unit. If I have y equals 3x squared, I can write a bunch of congruent parabolas. Negative 3x squared is congruent. It's the same shape, it's just reflected. Y equals 3x minus 4 squared plus 7, that's also congruent. Okay, it's the same shape, it's just shifted to the right 4 and up 7. So I can now put that into a question like number 5. If it's translated 4 units left, I know h is negative 4. If it's congruent to this parabola, well, I know that, now I have to ignore the a, I know that the magnitude has to be 4. Okay, the sign may or may not be negative, but congruency depends on the magnitude of a. Okay, so if I know the direction of opening is up, well, now I've solved it. I know that a has to be positive 4 because it has to be congruent to the parabola negative 4x minus 2 squared minus 11, but it's facing up. I also know it's translated 7 units up, so k is 7. So here we go. I get y equals 4, x plus 4 squared plus 7. So guys, you probably noticed that I skipped number 4, and what I'd like you to do now is please go back to number 4, and I'd like you to do numbers 4, 6, 7, 8, and there are 2 8s, so do 6, 7, 8, 8, and 9. Sorry, don't do 9. Do up to this page. I want you to pause the video, give all those other questions a try. When you come back, you can unpause the video. I'll display my answers and you can look through your work, and then we will continue by starting here with determining equations of parabolas in vertex form. Okay, so pause the video now and I will see you in just a minute. Okay, here we go. These are the answers to number 4. All right, let's move to number 9. What we're doing in number 9 is determining equations of parabolas in vertex form. Now, we haven't spent a whole lot of time on vertex form or calling this vertex form, but that's what this is named. And it's called vertex form because it's really easy to see what the vertex is. So I know my vertex depends on my horizontal translation and my vertical translation. My vertex is HK. Okay, So how am I going to use that to answer these questions? So number 9 says, find the equation of the parabola in vertex form if a equals 5 and the vertex is at -2, 6. So we're given a equals 5, but from the vertex, -2, 6, we know that h is -2 and k is 6. So all I have to do for this question is just replace the variables with the associated values. So this becomes 5x plus 2 squared plus k, which is 6. And that's it. That's the equation in vertex form of a parabola where the parent function has been stretched by a factor of 5 and the vertex is at -2, 6. To do number 9, we're going to have to do a little bit more solving. So in this case, I'm going to start with vertex form. And then I'm going to look at the information I'm given. So I know the vertex is at 5, -1, meaning h is 5 and k is -1. And it passes through 4, 1. So actually we aren't directly given a parameter, but what I can do is I can first sub in h and k. And then what I can do is I can sub in 4, 1 in order for me to solve for my unknown parameter, which is a. So my final answer will always have an x and a y in it, but my a, h, and k values should be solved. All right, so here we get 1 minus 1. So a is 2. My final answer, 2 x minus 5 squared minus 1. All right, so that's great when I'm given information. But what happens when I'm given a graph? Well, in the graph, I can figure out very similar information just by looking at the points. And I have to be careful here because, you know, I don't want to tell myself that that point is 3, 0 when it's not. I have to look pretty closely. So what I'm going to do first here is recognize that the vertex is at 2, -3. And I can write down my first line by subbing in the vertex. And then what I want to do is sub in one other point on this parabola. And I'm not going to do the one that I just showed you because that's not actually a nice point. But I see actually 2 different really nice points that I could use. So why don't we use this one, 3, -1, and I'm going to sub in -1 for y. I'm going to sub in 3 for x, and I'm going to solve for a. I get -1 plus 3 equals a times 1 squared. So that's, again, a is 2. That's a coincidence. So I know the equation of this parabola is like this. All right. Let's try the next one. And for the next one, I can kind of already see that, well, I know my a value is going to be negative. I also can sense that there's going to be a compression. But regardless of what the sign of a is, I always still start with my general form of a parabola and vertex form. And then the first thing I do is I sub in what I know for the value of the vertex. Okay, so what I'm trying to say here is you don't make this -a. You don't do that. It's going to come out in the wash when I do the calculation, okay, when I sub in the points. Now let's look closely here because I do actually think that this is an x-intercept. So 1, 0, let's use that. All right, so I'm going to put 0 in for y. I'm going to put 1 in for x. I get -3 equals a, -3 squared. -3 is 9a. And look at that. It does come out in the wash that a is negative and its magnitude is less than 1. All right. We're going to wrap this up with one last question. It's a word problem, but not really. What I want us to do here is come up with an equation to graph this, or to model this situation. So the owner of a small clothing company wants to create a mathematical model. Remember, we said this just means equation. Okay, for the company's daily profit P in dollars based on the selling price D, also in dollars, of the dresses made. The owner has noticed that the maximum daily profit the company has made is $1,600. I'm going to write this down. Max profit is $1,600, and this happens when dresses are sold for $75 each. The owner also noticed that selling the dresses for $50 resulted in a profit of $12.25. So guys, what we're actually given here, and it tells us here that it's a quadratic relation, so I know it's a parabola, but what we're given here is 2 points on the graph. So here, if it sold for $75, my profit was $1,600. How do I know that the 75 goes first and the 1,600 goes second? Well, I know that my price is the independent variable and my profit depends on my independent variable. So I'm going to call X, or I'm going to put it in first. I'm going to put $75 in the first part of my coordinate because I know it's the independent variable. Same with this. When I choose a sale price or a cost or a price of dresses of $50, I know my profit, or my profit becomes $12.25. So I can actually just sketch this, and I don't really know what this looks like, but I know that one of the points is 75, 1,600, and I know that another one of the points is 50, 12, 25. So if we want to write a quadratic formula for this, or a quadratic function for this, I know that I can start with my vertex. And then what I will do is I will put in another point on the graph, and I only know one. Oops, that should be squared. And I only know one. Okay, so this becomes negative 375 equals A times 625. So A equals negative 375 over 625. I'm not going to use decimals. I'm going to reduce this. This ends up being negative 3 over 5. So I know the function that models this situation is negative 3 over 5, x minus 75 squared plus 1,600. There we go. So guys, this last question we're going to do together as a group, okay? This this robot playing basketball we'll do next time. Okay? So please guys get through the homework, and I will see you soon.